Dilations, Lesson 6.4. The standard is 8G3. The objective is to use scale factors to graph dilations. The essential question is how can we best show or describe the change in position of a figure? Dilations create similar images. Angles are congruent and sides have same ratio, but they are different sizes. Scale factor is the ratio of an enlargement or reduction in size. So in an enlargement, the scale factor is greater than 1 and numbers are greater than 1. So reduction is a scale factor less than 1. So smaller numbers less than 1. So how to calculate scale factor? So this is how we set up the ratio. It's the new image over the original image. How to use the scale factor to draw a new shape. We multiply each coordinate, x and y, or side lengths, times the scale factor to get the image's new coordinate or length. So scale factor of 1/2. We can either multiply by 1/2, multiply by 0.5, or divide by 2. So to get a scale factor of 1/3, we multiply by 1/3 or divide by 1/3. Example number 1. A figure has vertices w, -2, 4, x, 1, 4, and y, 3, -1. Find the coordinates of the figure after a dilation with a scale factor of 2. So since they told us it's a scale factor of 2, we're going to multiply. Since I already have my coordinates written out, all I have to do is multiply by 2. So for w, I'm going to take -2, multiply by 2, that gives me -4. 4 times 2 gives me 8. Those are the new coordinates for w. Now for x, I have 1 times 2, that gives me 2. 4 times 2, that gives me 8. Those are the new coordinates for x. Now y, 3 times 2, that gives me 6. -1 times 2 gives me -2. Those are the new coordinates for y. So these are the new coordinates after the dilation. Example number 2. A figure has vertices L, -10, 4, M, 2, 5, and N, 8, -4. Find the coordinates of the figure after a dilation with a scale factor of 1/2. So since they told me it's a scale factor of 1/2, that means I'm going to divide. So I'm going to take each of my coordinates and I'm going to divide by 2. So -10 divided by 2 gives me -5. 4 divided by 2 gives me 2. Those are my new coordinates for w. Now for x, 2 divided by 2, that gives me 1. 5 divided by 2 gives me 2.5. Now those are the new coordinates for x. Now for y, 8 divided by 2 gives me 4. -4 divided by 2 gives me -2. Those are the new coordinates for y. So these are my new coordinates after the dilation. Example number 3. A figure has 4 vertices listed. Graph the figure, then graph the image of the figure after a dilation with a scale factor of 3. Since they told me it's a scale factor of 3, that means I'm going to multiply by 3. But first, I'm going to go ahead and graph my image. So f is at -1, 1. I'm going to start the origin, go to left 1, up 1. That would be f. Now g is at 1, 1. Start the origin, go to the right 1, up 1. That would be g. Now h is at 2, -1. Start the origin, go to the right 2, down 1. That would be h. Now I is at -1, -1. Start the origin, go to left 1, down 1. That would be I. Now I'm going to go ahead and connect my dots. and that would be my image. Now I'm going to multiply all of my coordinates by 3. So for f, -1 times 3 will give me -3. 1 times 3 will give me 3. Now for g, 1 times 3 will give me 3, and again 1 times 3 will give me 3. For h, 2 times 3 will give me 6, -1 times 3 will give me -3. And now for I, -1 times 3 gives me -3, and again -1 times 3 will give me -3. Now those are my new coordinates. Now let's go ahead and plot them. So for f, -3, 3. I'm going to start at the origin, go to the left 3, 1, 2, 3, up 3, 1, 2, 3. And that would be f prime. Now for g, 3, 3. I'm going to start the origin, go to the right 3, 1, 2, 3, up 3, 1, 2, 3. That would be g prime. Now for h, 6, -3. Start the origin, go to the right 6, 1, 2, 3, 4, 5, 6, down 3, 1, 2, 3. And that would be h prime. Now for I, -3, -3. Start the origin, go to the left 3, 1, 2, 3, down 3, 1, 2, 3. And that would be I prime. So now I'm going to go ahead and connect my dots. And since this is the new image, I'm going to go ahead and shade it in. But I'm going to shade it in like a donut so that way I can still see the pre-image. And that would be my final answer. And since my image is larger, it's called an enlargement. Example number 4. A figure has 3 vertices listed. Graph the figure, then graph the image of the figure after a dilation with a scale factor of 1/3. So since they told me it's a scale factor of 1/3, that means I'm going to divide. But first, I'm going to plot my points. So I have A is at -3, 6. So I'm going to start at the origin, go to the left 3, and up 6. 1, 2, 3, and then up 6. 1, 2, 3, 4, 5, 6. That would be point A. Now point B is -3, -3. I'm going to start at the origin, go to the left 3, 1, 2, 3, down 3. 1, 2, 3. That would be point B. Now C is 3, 0. I'm going to start at the origin, go to the right 3, 1, 2, 3, and I'm not moving anywhere else because it's at 0. So that would be point C. Now I'm going to connect my dots. And that would be figure ABC. Now I'm going to divide each of my coordinates by 3. And we'll start with A. So -3 divided by 3 will give me -1. 6 divided by 3 will give me 2. Now B, -3 divided by 3 will give me -1. And -3 divided by 3 will again give me -1. Now for C, 3 divided by 3 will give me 1. And 0 divided by 3 will give me 0. Now let's plot our points. So A, -1, 2. Start the origin, go left 1, up 2. That'll be A prime. Now for B, -1, -1. Start the origin, go left 1, and down 1. That'll be B prime. Now C, 1, 0. Start the origin, go to the right 1, and we stop at 0 because it's at 0. So that'll be C prime. Now let's connect our dots. Now, since this is my image, which is also my answer, I'm going to go ahead and shade it in. Now, since this is a scale factor of 1/3, it is called a reduction. Example number 5. Lucas wants to enlarge a 3 by 5 inch photo to a 7.5 by 12.5 inch photo. What is the scale factor of the dilation? So this time we're looking for the scale factor. So that means we're going to take the new image and we're going to divide it by the original. So I know that the original is 3 by 5 inch. And the new is 7.5 by 12.5. So I'm going to take 7.5, which is really 7.5, and I'm going to divide it by the first digit, which is 3. And I'm going to do it one more time to make sure I get the same answer. So I'm going to take 12.5, which is really 12.5, and I'm going to divide it by 5. So what ends up happening when I divide both of them, I get 2.5. Since I get the same answer, that means that the scale factor is 2.5. Example number 6. Calculate the scale factor of the dilation below. Now remember, when we're looking for scale factor, we want to take the new image and we're going to divide it by the original. Now in this case, DE is the original. And the new is going to be D prime, E prime. So what I'm going to do is take the changes in Y and the changes in X and I'm going to scale accordingly. So first I'm going to start with my new image and I'm going to draw my line and count my units. And that ends up being 8 units. Now I'm going to do the same thing for the original. I'm going to start by drawing my line. And that's going to be 4 units. So 8 divided by 4 is going to give me 2. Now I'm going to do the same thing, but I'm going to do it for my x's this time. So I'm going to start with my new image. I'm going to draw my line. And that's going to be 2 units. Now I'm going to go to my original. I'm going to draw my line. And that's going to be 1 unit. So 2 divided by 1 will also give me 2. Since they both gave me the same answer, the scale factor is 2.